Hello and welcome to this month's CCAG meeting. Today we're asking the question, what links the continent of Africa with the Arctic? The fact is, many people might struggle to see the link. One is icy and inhospitable, a faraway region that few of us will ever visit. The other is home to well over 1 billion people, a vast, incredibly diverse continent of many countries containing deserts, rainforests, and grasslands, as well as a huge, intensely developing cities. But there is an incredibly important link. The Arctic is warming faster than anywhere else on the planet due to human-caused climate change. And this warming is triggering extreme changes in weather systems around the world, including those across Africa. What happens in the Arctic does not stay in the Arctic. And this affects all of us. I'm joined today by CCAG's Sir David King, Professor Johan Rockström, and Dr. Fatima Denton to talk about the impacts and indicators of these changes and the actions that we can take to avoid the most devastating consequences. Now, our conversation takes place at a particularly troubling moment, almost in the same breath that the energy companies are announcing record-breaking profits. They've also signaled that they're intending to roll back their commitments to reduce investments in fossil fuels. We seem to be ramping up fossil fuel exploitation when we should be making drastic reductions, even as we approach critical climate tipping points. So today we'll be looking at the implications of such decisions. First of all, I'd like to start off with Dr. Fatima Denton by focusing on the impacts of climate change on African countries. What are some of the effects that people are seeing, Fatima?
Thanks, Ade. I think when we talk about climate change and link that to Africa, there is definitely a sense of disproportion in terms of the impacts of change happening in a disproportionate manner in a way that is affecting all the development sectors. Africa is very much a land-based system, very much reliant on land-based system, and therefore climate is a resource. It's a resource to African economies. So we are seeing the degradation of impacts, I'd say, in several systems, in food systems, in energy sector, in energy systems, agriculture, lands. These are all things that are affected. As I said before, many people rely on agriculture in Africa. That degradation that we are seeing in terms of our land systems is affecting food security. It's affecting people's ability to produce. Reduction in rainfall is also affecting agriculture. The erratic nature of rainfall, the precipitation and variation in precipitation as well. These are all factors that are undermining African economies and undermining the productivity in the continent, especially when it comes to smallholder farmers who are no longer able to produce in quite the same way that they were able to do so. There's also the fact that the continent, the climate system in the continent in itself is a very complex one. And the complexity of that means that it's very difficult to, predict the types of weather patterns that one can expect. It's also a continent that doesn't have very much in the way of, I'd say, some of the information and knowledge that we need to curtail some of these impacts are not available. Some of the tools, the observation systems that we need that are readily available in other parts of the world, are not available here. So the importance of data and being able to use climate data in a way that supports African farmers and their planning systems. An average farmer would have 30 odd decisions to make. And all of those decisions are affected by by climate as an important resource. So these are some of the difficulties. But beyond that, I think also the insecurity produced by climate impacts is also one where we witness and we can see it in terms of beyond the food systems. We can also see it in terms of our water systems. I think the impacts are felt also through our hydrological systems that are in place. And this is affecting also development in a big way. But beyond also the water systems and the stress that is causing, we are also seeing what we call slow onsets. We're seeing frequent floods. We're seeing droughts that are occurring in this part of the world. And again, as I said, because the continent is so land-dependent, land-based, this is affecting food security. So these extreme events that are becoming more of a norm are reducing the productivity of farmers, the income that comes with it. On the wider scale, I would say our ability to realize the sustainable development goals is going to be much compromised because of the impacts of climate change.
Fatima, you paint a very stark picture of what's going on in the continent of Africa and how it is being affected by climate change. And you touched a little bit on some of the mitigating measures and the difficulty of the mitigating measures. And later on, we will talk a little bit about what can be done to mitigate the issues and the effects of climate change on the Arctic. But are there some mitigating measures that are possible to implement across Africa? For instance, could mangroves play a role, or for example, different types of crops?
It's important to say that the continent has solvable problems. All the problems related to climate change are solvable. And the continent is probably one of a few continents that can actually claim to have the space where all these problems can be solved. From food security or food insecurity to energy insecurity to issues related to infrastructure, and how that is also going to be undermining existence for vulnerable communities. I think we can all see that the continent does have the space, does have the ability to resolve these problems. So as I said before, looking at specific crops, I think would be important. Thinking about how we build strong flood defenses as well, because flood is becoming a regular occurrence. So how we do that, I think would be important. I touched earlier on the fact that we don't have the relevant data. So having the relevant climate observation systems that can help us plan in advance, that can give farmers the ability to make strategic choices, that can support governments as well. I mean, the difficulty in this continent is that we planned, but with very short cycles. And climate change is something whereby we need to look way ahead into the future. So therefore, having the relevant information and the information that would be beneficial to end users, beneficial to farmers, but also for planning purposes, I think would also be very useful. So mitigation measures do exist, but as I said before, we need to find information and strategies that can be intersected and linked with policy. Climate change is not just a biophysical problem, it's a political economy problem, it's a societal problem.
So many interesting points there, Dr. Denton. And one which I really like is the fact that you mentioned that the solutions are there, and that's really important to get across to people, because for so many people, when they hear climate change, they feel like it's hopeless and they feel like they're powerless. But I think what strikes me is it's about a proper, truthful mindset change. on all levels, from the layer of the public all the way up to governmental level, and a mindset change to realize that pretty much everything we do politically, socially, has to be geared towards tackling climate change. Now, when you talk about the mitigation and you talk about the solutions, one of the things that's really important with the continent of Africa is justice. You know, it's an issue that has always plagued the continent for centuries. So my question to you is, what needs to be done now to make sure that as we transition to cleaner energy, that this is a just transition for those countries in Africa?
I think the first thing to do is recognize that there is an inherent injustice to the climate problem. I think that recognition is important, because you can't fix a problem if you don't recognize the extent of the problem. So equity is an essential component of enabling the transition. We're not going to be able to achieve a transformational change and an equitable change if we leave out or if we discount many of the inequities. And let's not forget, some of these inequities are not just climate related. We're talking about a continent that is well rehearsed with matters of inequities. There are all kinds of structural inequities, and these inequities are already there. They're already set in place. So what we're saying is that with climate change, we are now seeing some kind of a layering of other kind of inequities that are going to now take over. And that's what we need to avoid. We need to avoid creating greater hardship for people that are going to be paying the heftiest price for adjusting to this change are the very same people that have not contributed as much to the problem.
I guess what it sounds like is that climate change is really highlighting those old injustices and inequities that have been felt by countries in the African continent.
Very much so. I think they all become almost flayed up by climate change, and a lot of the problems are problems related to different types of asymmetries that I see. First of all, as I mentioned, the definition of the problem or the definition of the solution is very often not in the hands of those that are facing the challenge and the problem. And that's an asymmetrical relationship that needs to change. If you want to see an accelerated change towards a just transition, those that are exposed to the change, exposed to the challenge, exposed to the problem, need to have a say into how the problem can be fixed. The transition that we're talking about is more than just, securing the dignity and the rights of people. The transition we want to see is about reconfiguring a different economic system. There is a huge exercise of reconfiguration that is going to be essential here. Very often when we talk about just transition, we reduce it to jobs. But this is a whole of society approach. Jobs are going to be affected. That's the first indicator of an unjust system. Jobs will be affected because jobs that are intensively related to, I would say, emissions would be the first casualty. So jobs will be affected, especially as we're thinking about carbon-intensive jobs. But I think it's also looking at our current economic system and asking ourselves whether this is fit for purpose. One word that I often hear is an orderly transition. No, I don't see how the transition can be orderly. We have to be prepared for a messy transition. We have to be prepared for a complex transition. And the complexity is in the resources that we bring to the table, but also in terms of how we bring everybody on board. And that's why I was saying that, of course, it's important that rights are protected. Of course, it's important that the dignity of people and the security of people are not compromised. Those things are a part of our value, they're part of our culture. But I think we want to also say, how do we get out of a model of economy that is very much contingent on production and not looking at ways of replenishing, ways of growing ourselves out of a system that is, to a large extent, not creating the kinds of outputs that we would need to ensure that the transition is justice-based.
Dr. Fatima Denton, some very powerful and really interesting points. I mean, it's hard to unpick all of it, but I feel one of the things you're alluding to is, on a fundamental basis, climate change is challenging our systems, on a systematic level, how we run countries. And maybe it's time for us to sort of think differently in the way we run our planet systemically. And for a lot of people, that might sound scary, that kind of change. But ultimately, what's scarier is the unknown that we're going into if we do not find a way to tackle and enable people to tackle climate change. Fatima Denton, thank you so much for that. Now, listen, I'm going to shift the focus to the intense warming and melting that we're seeing in the Arctic. Professor Johan Rockström, perhaps you could begin by explaining to our audience something that is talked about so much scientifically and so much in terms of climate change, and that's tipping points. What is a tipping point, and why are there so much concern around the Arctic tipping points, Johan?
Yeah, thanks, Ade, and I'll be kind of giving the physical dimension of Fatima's really convincing overview here, and I would argue that what the physics show is that we are indeed so interconnected that the nation state is no longer an adequate unit for governing our future, because we're so interdependent on all the tipping point systems on planet Earth that if something goes wrong in the Arctic, it hits back across the entire Earth system, and the most vulnerable are most hit in that journey. And I'll give you an example of the scientific evidence of that. But what is a tipping point? Well, a tipping point is the following. We have ample scientific evidence that everything from lakes to forests to peatlands to ice sheets to the big overturning systems of heat in the ocean have multiple stable states. They can exist in several stable positions. So you can have a stable rainforest. But if you push that system too far, you will pass a very specific point, a very sharp, narrow point in physics, chemistry, and or biology, beyond which the system irreversibly shifts from the state you've been in, rainforest, into a shift towards a new state. And for the rainforest, we know what that is. That's an irreversible transition into a savanna state. You push a savanna too far, and it will irreversibly shift over into drifting away into an arid, desertified state.
Johan, sorry to interrupt, but when you say irreversible, are you talking about that's it now? Is this that once things change, we will never be able to turn them back, or is this something that will take centuries to turn back?
No, from any human relevant time scale, it is irreversible. You cannot exclude that it's possible to reverse in kind of hundreds of years, but you lock in the system over at least a century in the wrong direction. And why is that? Well, it's because what happens when you cross a tipping point is that the processes, the so-called feedback dynamics that run the system, change direction 180 degrees. So the logic shifts fundamentally. So go back to let's go to the Arctic. So the Greenland ice sheet in a healthy state is a white slab of ice, which reflects back 90% of incoming heat from the sun back to space. So it's internally and on planet Earth a cooling system. It's a mirror of incoming heat. That's the feedback. It self-cools itself thanks to the white color. A white surface reflects heat. When that starts melting, the surface of the ice sheet becomes darker and darker because of pollutants, but also because of liquid water. And at a very specific point, it shifts from reflecting more heat to absorbing more heat than it did before crossing the tipping point. So the system becomes a net absorber of heat instead of a net cooler. And at that point, you cross a tipping point. What happens then is that it starts self-reinforcing. It starts like, you could think of it as a ball rolling down a hill. You know, you push the ball up the hill, you come to the top, and then you just let it go, and it starts rolling, and it rolls just faster and faster and faster, because the darker it gets, the more heat it absorbs, the warmer it gets, and the faster it melts. That's the tipping point. That's why it's so difficult / impossible to turn back. And the most established tipping point dynamics is ice. Ice melts, gets darker, absorbs more heat, and it gets into this this vicious cycle of self-amplified warmer. It can go the other way around, by the way. The reason why we enter ice ages on planet Earth is not, as many people wrongly believe, that we simply, that the distance between the sun and planet Earth gets longer and longer and longer and just gets colder and colder. Oh no, what happens is that, yes, it gets slightly colder because of the distance to the sun in the beginning, and then the ice starts growing. When the ice starts growing, the planet gets whiter. The whiter it gets, the more it reflects heat back into space, and it goes into a spiral in the other direction. It gets just colder and colder and colder. So that's what we call a tipping point. And so we're always looking at the mechanics that keeps the system stable. A rainforest. Well, why is it called a rainforest? Well, it's because it generates its own rainfall. That's the feedback in the rainforest. It is so dense in its canopy, it's so moist, it generates roughly 40% of its own rainfall. It self-wets its rainforest system. If you cut down those trees, you have too much global warming, the system opens up, it dries out, and at a very specific point, it crosses a tipping point, and it goes from self-moistening to self-drying. And oops, it drifts off and becomes a savanna. That's the tipping point. So this is well documented now for 16 big climate tipping element systems on planet Earth. The boreal permafrost, the overturning of heat in the North Atlantic, rainforest systems, ice sheets. We have quite a good handle on these tipping point systems today. The big drama around them is that they impact the planet because they lead to self-reinforced warming, which is exactly what we must avoid at all costs today. But secondly, it also impacts people. It has implications on people. And that's where you started off this session, which is that what happens in the Arctic does not stay in the Arctic, because what we now can show scientifically is the following. The Arctic is warming 4 times faster than the planet on average. This is just extraordinary. It means that the Arctic is actually planet Earth's ground zero on global warming. Nowhere on planet Earth are things so dramatic as in the Arctic, changing so fast as in the Arctic. This means that the Greenland ice sheet is releasing massive volumes of cold fresh water into the North Atlantic, just up in the Gulf Stream area. This slows down the whole overturning of heat in the ocean. We know of you probably heard of the ocean conveyor belt, which is a thermodynamic engine pushing currents of water across the oceans in the Atlantic, but also in the Pacific and in the Indian Ocean. It works. It's very sophisticated, but it's very simple fundamentally. It's a thermal haline pump. So very warm saline surface water is flowing from the Southern Ocean, from Antarctica, up to Greenland, releases heat, which makes it livable in Scandinavia, for example. this very heavy salt water then sinks to the bottom and drives the pump, that's the engine, and then the water flows at the bottom of the Atlantic back down to the Southern Ocean, and this is how it circulates. When the Greenland ice sheet releases all this fresh water, it dilutes the saline water. The water gets less heavy, so the pump reduces its speed. It simply doesn't sink as fast anymore. The whole overturning of heat slows down. We've proven that it's slowed down so far with 15%, 15%. This slowdown of the whole overturning of heat in the North Atlantic pushes the monsoon systems further south. What that means is that you get less rainfall over the Amazon rainforest and more forest dieback and more forest fires, releasing carbon and destroying biodiversity on the Amazon rainforest. This is now the most well-researched impact on the monsoon. But there is also scientific indications that pushing this overturning further south also impacts on the African monsoon by changing the eastern equatorial Atlantic, the heat exchange in the surface water in the East Atlantic, just on the west coast of Africa, which in turn impacts on rainfall provisioning over the Sahel region, which can explain higher degree of extreme events and more drought conditions in the West African monsoon, which then ties back immediately to Fatima's point about vulnerability and food insecurity hitting on the continent, where, by the way, one should remember, 40% of African people live already today in water-scarce regions. I mean, even before you have global warming, in a continent where 97% of the food production is small-scale rain-fed agriculture. So you can see how the Arctic, via the North Atlantic overturning of heat, is impacting on the monsoon and just amplifying the extreme impacts on food security and therefore also vulnerability in Africa.
Wow, thank you, Professor Johan Rockström. And thanks for connecting the science with the impact it has on people, because I think that's so important that we understand that. Can you now talk to me a little bit about the Thwaits Glacier, or the so-called Doomsday Glacier? You know, what is it? And is this tipping point the biggest threat to the Arctic and the rest of the world?
Yeah, so the Thwaits Glacier is one of the many glaciers in Antarctica. It's on the West Antarctic ice sheet. And I'm really glad you raised this, because this is one of the perhaps most important Earth system science findings of recent years, that what happens in the Arctic does not only does it not stay there, it actually is connected through cascades all the way down to Antarctica and the Thwaits Glacier. So it goes via the ocean. The ocean, by the way, is what connects basically all the systems on Earth. So the Greenland ice sheet melts, slows down the overturning of heat. When this slows down, this means, of course, that less warm saline water flows from the Southern Ocean up in the North Atlantic. It gets stuck in the Southern Ocean. And Antarctica is a very special ice sheet compared to the Arctic. The Arctic is essentially ice on sea. So it contributes less to sea level rise when it melts. It contributes equally to warming because it gets darker and absorbs more heat, but less to sea level rise. The Greenland ice sheet is special because that is a slab of ice on rock. So the Greenland ice sheet represents 7 meters sea level rise. But Antarctica is ice on rock. And the Thwaits Glacier is one of the glaciers on rock closest to the sea in the West Antarctica. And what happens is that when the Greenland releases so much cold fresh water, slows down the overturning of heat, locks in more saline surface water in the Southern Ocean. This means that the Southern Ocean warms even faster than the global average. And the way Antarctica is melting is that it's melting from below. It's not melting from above. It's not like a piece of ice standing on the table and just melting. Oh no, it is melting by being lubricated from warm upwelling of ocean water from below along the surface of the rock that the ice sheet is standing on, which means that the Antarctic ice sheet is breaking and falling into the sea from this upwelling of warm water coming from below. And that's what's happening with the Thwaits Glacier. It is sliding into the ocean because of this melting from below, caused by the lubrication from warmer surface water, which is warmed by our fossil fuel emissions in general, yes, but it's amplified because of the Arctic. The Arctic is actually locking in even more warm water. And that's why we from the scientific side, been very surprised to see how fast the West Antarctic ice sheet is collapsing. And one explanation is very likely that we have this link up to the Greenland ice sheet and the Arctic. Now, finally, what is Thwaites? Why is the Thwaites Glacier called the Dooms Glacier? Well, it's not because it represents a very large number in terms of sea level rise. It's because we very likely have a situation where if we lose the Thwaites Glacier, it's like, taking off the top of a bottle and outpours all the glaciers, because it's the glacier that holds many glaciers up rock from Thwaites. So the fear is that when that one slides into the ocean, then you'll just have more and more glaciers just continuing to slide behind it. It's a plug. It keeps the West Antarctic ice sheet glaciers intact. And this is what we have not seen yet, but we may be seeing a kind of an abrupt release of ice sheets. Now, the Greenland ice sheet, together with the West Antarctic ice sheet, if they would entirely melt, represents 10 meter sea level rise, 10 meters. So we're following a path that will take us to, according to the Intergovernmental Panel on Climate Change, to in the order of 1 meter sea level rise by the end of this century, assuming that we don't have any tipping points, and we won't have any abrupt continued melting, neither in the Greenland ice sheet nor on West Antarctic ice sheet. But if these cross tipping points, then that number 1 can jump up into becoming at least 2 meters already by the end of this century, and then it would just continue. It would be, again, irreversible. We would simply slide towards higher and higher sea levels over the centuries to come.
Mm. So basically, if we cross these tipping points, it will throw out all of our scientific predictions out the window and change everything completely.
Yeah, it would definitely change the rate, and therefore the position. Yeah, the curves would become steeper.
Thank you, Professor Johan Rockström. I mean, that was in part pretty scary, but very illuminating and really important message. I mean, if you're not sort of alarmed and thrown into action by that, I don't know what will do it. So no, thank you so much, Johan. I'm going to move on to Sir David now, and actually, before I move on, I also should mention that this week we've also had news that the Antarctic sea ice has reached a new low, which emphasizes even more the point that Professor Johan was making there. But as I said, let's move on to Sir David. I'm keen to get your insight here, and much of your work is focused on how we might be able to repair or at least slow down ice loss. Could you shed some light on this? Is it possible to repair damaged regions in the Arctic or Antarctic? These sounds like things from a science fiction movie.
Yes, I know. I think the answer to your question is we don't actually know, but we are certainly making efforts to see if we can. There are quite a few groups around the world now working on the possibilities around refreezing the Arctic, if I could phrase it in that way. We might be able to achieve this before it gets too far. Listening to Johan, you will have understood that at some point, there's nothing we can do to stop the flow of water from Greenland, etc. Let me also add, to stop the emissions of methane trapped in the permafrost in that region, which will give rise to a very big potential temperature change around the whole world. So I think there is a tremendous incentive. Let me say one more thing about the incentive. Johan hasn't had time to refer to the jet stream. The jet stream flows in a circular anti-clockwise motion around the Arctic Circle region, and it's a strong wind which has kept the cold air up in the north around the North Pole region and the warm air from the equatorial region separated, and keeps places like the United Kingdom, Northern Europe, and America, the United States, it keeps them warmer than they would otherwise be. Now, what happens as a result of what Johan has been describing, warm air going up into the upper atmosphere, even the lower atmosphere, and that has been impacting on the jet stream. And the impact of this change is really extraordinary. We have seen along the west coast of the whole of Northern America, temperatures in excess of 50 degrees centigrade during the summer. This is a lock-in of the jet stream in a very distorted form. Instead of just flowing around the North Pole region, it is so distorted that it travels in a north-south direction and then a south-north direction. It is massively distorted, impacting on the entire world's weather systems. And all these extreme weather events we're observing already can be probably attributable, most of them, to what has been described in the Arctic Circle region. So we have a massive incentive. Loss and damage around the world, difficult to estimate. Not only are these insurance losses, reinsurance losses, because most of the areas that have suffered loss and damage are not insured, but we are probably talking about $250 billion worth of loss and damage around the world already occurring every year. So we have the incentive to look at significant projects that might be capable of keeping the North Pole region cooler during the North Pole summer period. The North Pole summer period is only about 3 months. But today, the ice that is formed over that blue Arctic Sea during the Arctic winter rapidly melts. And again, that blue sea exposed, maybe 40-50% of the Arctic Sea now exposed to summer sun during those 3 months. And the air above the Arctic Sea warms rapidly. Greenland, as we've just heard, beginning to melt, and it is heading towards irreversibility. And equally on the permafrost regions, very extraordinary high temperatures have been observed. So what we want to do, we are particularly working on one technology, and that is to cover the Arctic Sea region during those 3 polar summer months with white cloud to reflect sunlight away from the ice formed during the polar winter. That's the answer to your question. But I'm going to wander away from that and just talk about the business of adaptation for a minute, because if we are looking at the countries in Africa, what do we need for serious adaptation? Yes, we must engage local people in the countries. We must do that. It's absolutely essential. Those few billionaire philanthropists who believe they know what African countries need and dictate from afar are not understanding exactly the point that Fatima is making. It's the local people who know their region extremely well. In every country, people have adapted to the climate they have. And as the climate changes, and changes rapidly, this adaptation process is extremely painful. So we must be talking to them. But the second thing is, we need to also understand the extreme variability in the demands of adaptation. I've been working closely in the most densely populated country in Africa, that is Rwanda, which sits virtually on the equator. It's quite high up, about 4,000 or 5,000 feet above sea level. And it has extreme differences between east and west. This little country in the east, we have they have a watershed, and it's the Central African watershed of mountains, which separates out the water that travels towards Egypt and forming the Nile River. And on the other side of the watershed, all the water is going into the Congo River, goes off into the west. So what you have as a result of this watershed is an extreme version of the differences in predictions of climate change. On the western side, higher rainfall, increased rainfall is as challenging to farmers as reduced rainfall. And on the other side of the watershed, on the eastern side, exactly the opposite. Desertification, the tendency towards much less rain. So what we need is the predictions that are now available from those who are modeling climate science going forward in time, the predictions for each region in Africa, so that we can at least advise the Africans present in those regions for using these models on how to proceed. While I was working in Rwanda, we got the British Meteorological Office to use their predictions down to a fine pixel range for Rwanda alone, and that helped Rwanda to develop their climate resilience policy going forward in time. This is one of the leaders in Africa on having now for 13 years had a climate resilience policy in place. So I just wanted to emphasize the importance of good information being made available to each of these different regions. And by the way, of course, Johan is right. Nation states are no longer really adequate. We've got a big challenge there. But that watershed, of course, from Rwanda, we go into Uganda and Tanzania and even Kenya. So we know that on the eastern side there are similar challenges, and on the western side, off we go into the Democratic Republic of the Congo and so on. There are commonalities across borders as well as differences. Then I just want to say one more thing, and that is the availability of renewable energy systems, which results from the commitment made particularly by European countries, and I would say led by Germany, Britain, Italy, France. They were all joining in around the late 1980s, 1990s to develop a process of subsidizing people who wanted to develop photovoltaics for their own electricity generation or wind turbines, etc. And the result was a massive fall in the cost per kilowatt hour of installing renewable energy systems. So today, for countries between the tropics, the cheapest way to produce new electricity is renewable energy systems. Now, that is a message that hasn't really got across, which is why we continue to see the old fossil fuel energy systems being constructed. And as Africa's economy develops, and it's Fatima that has emphasized this point in the past, as African countries develop, if they continue to invest in fossil fuel, they will simply be creating stranded assets. Whereas if they switch early to renewable energy systems, they will secure all of the benefits. You're getting energy from the surroundings in your own country. You're not paying large amounts in dollars to other countries for their oil, gas, and coal. It is a very, very distinct advantage for most countries to make that switch. There is, of course, another big advantage. Because energy storage systems are now appearing that can deal with entire villages, it means that renewable energy can be put into villages without having to extend the grid. So the cost of this whole process is very significantly reduced. So I just wanted to take the opportunity of giving a very broad contribution to this very important discussion. I think the importance here is also focusing not only on local people living in the wealthier parts of countries within Africa, within other parts of the world as well, but also focusing on the indigenous people who live in the forest regions, focusing on the indigenous people who live on desertified areas and learning from them. This isn't focusing on them, telling them they should follow our example. I'm saying we need to learn from those people. I also would love to just briefly support what Fatima said, which is, I know, very challenging. And that is in connection with reconfiguring our economic system to a new system which is fit for purpose to face the challenges that we're now talking about. I'm afraid our economic system today doesn't meet the challenges. We talk about the biggest market failure ever being the climate system challenges, the climate risks that we're now faced with, the biggest market system failure. If that's a big market system failure, don't we actually need to re-examine the global economic system, the national economic systems in the light of this to move forward? So I think many things that have been said, Ade, have really carried forward this important fact. We need the information from the scientific community to be broadcast around the world. We need the information that they are pointing at to be understood locally by local people so that we can work with local people to develop solutions to the problems that climate risk faces them with. We need to be humble in that process. We need always to be not just listening, but traveling out there, talking to local people. And as I said, learning from those people who traditionally have understood the importance of their ecosystems. And that's where I'm referring again to the indigenous people of the world.
Thank you, Sir David King. I mean, there's so much more we could talk about today, but I'm afraid we've run out of time. I know you said that was broad, Sir Dave, but I mean, it definitely shed light and had so much positivity that there is hope. There are so many things that we can do, but it's going to take change. It's going to take change. So I just want to thank Dr. Fatima Denton, Professor Johan Rockström, and Sir David King for taking us on that sociological, political, and scientific journey on the things that we have to do in order to deal with the challenges ahead. Now, whatever you've learned from this stream, please spread the word. It's so important, as Sir David said, that we get this information out there, and that more people understand on every level what is needed to tackle this most important of challenges for the human race. So, as I said, I'm afraid that's all we have time for today. Thank you so much once again, Professor Johan Rockström, Dr. Fatima Denton, and Sir David King for joining us today. And thank you for watching. We look forward to seeing you at our next meeting. Goodbye for now.